Hey, so welcome back, and this is another daily LeetCode problem. So today it was actually another kind of design question. And so this one, you're given a browser history, they call it. And so it's question 1472, and it's literally called design browser history. So it's a medium level question. And what we're going to do is we're going to implement this class using a linked list, actually. There is another way you can do it. You can also use it using two-stack. Where you have kind of two individual stacks and you kind of push and pop from them both. But I find it kind of lends itself better to a doubly linked list question because it's very simple and intuitive to think of kind of going forwards and backwards in a list. And so let's go ahead and take a peek at this. So what you have is a couple different methods here. We want to be able to visit a website, to go backwards in our history, and then forwards. And then the main thing you really have to understand is if you go backwards in history, so say if you do, let's get out this here. Say if you go to like YouTube, and then you go to Google, and then you go to Facebook. Let's say that we then say, okay, I want to go back a page, and then go to Google again. And then you call the visit. So then you say, okay, now I want to visit like LinkedIn. So what you actually do is you go down a different path now, and so you can't actually go to Facebook anymore, so that gets kind of removed. So then you go down to LinkedIn, and then like whatever, Yahoo, etc. And say you want to go back to YouTube, and then you visit a page from here. And so then you're at the YouTube level and you say, I want to visit Facebook. And so now you're at Facebook. And basically everything else, since that's down a different path, gets removed. Okay, so that's kind of how we're doing it, is we're just kind of visiting websites, going back in history, and then we might go down a different path, which clears the other path. All right, and so how we're going to implement this using a linked list, let me quickly show you. So let's just maybe delete this here, is we'll have a linked list. And let's just say we start with like Google. That is our initial kind of home page that we're starting with. And so this is going to be a node. Oh, sorry. And so from Google, we then might visit, the next one might be Facebook. Let's go here, we have Facebook. Right, and so this is another node. And so we're going to be using a doubly linked list. I don't know why I can't draw today. Go on Facebook, and then since it's a doubly linked list, you'll have a pointer backwards, and that allows you kind of move forward and backwards in the list. And so say from here, we want to visit LinkedIn. And so you can kind of understand that as we're kind of visiting these pages, we'll also kind of have a pointer like you need in a linked list. Oh, I just need some red here for a sec. And just draw this node around there. And so we'll actually have a pointer that's kind of iterating through here. And so initially when we were at Google, the pointer was set here. But when we visited Facebook, our pointer was now here. That was like the current node or the current page we're looking at. And then the pointer is now at, LinkedIn. And so say if we want to actually kind of backtrack and go, move backwards now, we could say, okay, now I want to visit Facebook. And so then this method would return the name of the home page that we're at, which is Facebook. So say if, okay, now I want to go forwards. And so you go back to LinkedIn and you would return LinkedIn from this forward step. But say now, okay, what if we just kind of get rid of all this quickly. And so say now we want to step all the way back to Google. Okay, so we kind of go back to Facebook and then back to Google. And say then we want to visit another page from our Google search. And so what that's going to do is we're going to now go down a separate path and set its next pointer over here to whatever we visited, like say TikTok. Okay, so now we're on TikTok. And so then, because this pointer from Google is now looking at TikTok, and TikTok back to Google. Oh, I think my mouse is a little laggy. is you can actually just erase all of this kind of history that we no longer need because there's no longer a way to get to it. Like it's going to be kind of deleted in garbage collection. And so because the Google pointer is now pointing at TikTok and no longer at, like, I think Facebook was here, it just kind of goes away because no, like, you can't get to it anymore. All right, and so that's kind of how you deal with kind of moving forwards, backward in history, and then the edge case of, okay, what if we go back in history and we visit a site from there? All right, so let's go ahead and implement this algorithm. So what we'll do, and maybe I'll just kind of make myself look bigger here. There. And so initially what we need is another class called node, since we're dealing with a linked list here. And so, oh, we don't need this bracket. And we need to create our constructor. And it'll be a pretty simple class where we want to set a kind of current URL, a next pointer, and a previous pointer to kind of mark, okay, where are you going forwards and backwards in history? So we set our URL, and we'll set it initially kind of to empty if you don't specify it. And then we'll have our previous pointer and then our next pointer. Okay, and so we're going to have those 3 instance variables, and we'll set it equal to those there. Oh, I can't type. Great, and so that is just our kind of node class. It's just a node that points forwards and backwards and has a value itself. And so from there, what we're going to want to do is we're going to have a current node that we're looking at, and this is going to be that pointer in our linked list that's marking, okay, we're at this node, now we're looking at this node, and so forth. And so what we do is we create a node, and then we just initialize the URL equal to this home page. Okay, and so initially its previous and next pointers would just be pointing at none here. Great. And so now we want to be able to visit a page. And so for this, all you have to do is say, okay, what we want to do is we want to take our current node and set its next pointer equal to that URL, and it's going to need to initialize a new node with that URL. Great, and so the next thing that you're going to do is you also have to think, okay, this is a doubly linked list, and so we need to manage, okay, its previous pointer for this kind of new node that we made. And so we just grab this, and so that new node that we just made, we're going to set its previous pointer to the current node. Okay, and so that's allowing you to say, okay, we just made a new node, a new page. Say we just visited Facebook. Well, we have to set its previous page that we were just at to Google. And so now, since we just visited a new page, we have to set the current node equal to what we just made. Okay, and so now these two methods, you might be able to kind of understand that they're going to be basically the exact same logic except a little inversed, but thankfully we'll be able to kind of copy paste it a bit. So for this one, what we want to do is we want to go back in history, and we can go at most. It's really kind of clearly defined that we want to go at most here. They set it in bold, at most this many steps, because what if you specify, hey, I want to go back 20 pages, but you only have 1 page or 2 pages of history. So you only go like really at most 20, but in that case, you only go like 2 pages backwards. And so what you want to do is say, okay, while we have a current node dot previous, since we're going backwards, because that avoids us throwing an exception on like trying to go like, okay, we've reached nothing, and now we're trying to go previous to that, which would error out. So while we have a previous and our number of steps remaining is greater than 0. Since we only want to go at most this many steps. So all we do is we just set our current node is equal to our previous node, and we decrement our count. And then finally, since we just want to return the URL of the page that we're now at, we just say, okay, return our current node's URL. And so now when we want to go forwards in history, we just want to do the exact same thing, but say .next. Great, I think that works. Let's give that a run. I think there's an error. Yeah, this is annoying. I had to put self in front of all these. So let's just grab that and yank it here. So we're kind of referring to our instance variable up there. Let's try that again. Accepted. And correct. So yeah, that's today's daily LeetCode problem. It was another design one. I think these are very common in like interviews, sometimes common in like kind of programming competitions, not as common, but totally useful to learn. When people say, okay, like LeetCode isn't very useful for on the job, well, this is definitely something that is useful, creating a class and be able to understand data structures and the trade-offs of using them and knowing, the performance of your algorithm. So yeah, I hope this helped, and good luck with your rest of your algorithms. Have a great day.